Hello, in this video I'm going to work on a few revision problems involving quadratic inequalities, and basically just start with some more simple questions where one just essentially has to solve the quadratic equation that's given, then sketch the graph of the quadratic function, and then understand how to use that sketch to find the required set of values. And so for instance, to start, say we are told, stated to find the set of values of x for which x squared minus 11x plus 24 is less than naught. Okay, so really, when one is given a problem like this, and the entire quadratic is already set to one side of the inequality, all you really need to do in this case is just solve the quadratic to start. So we're just going to set this equation to equal 0, so it'll be x squared minus 11x plus 24, and of course that's set to equal 0. Now we just need to solve this quadratic to find our two solutions, two values for x. So AC is 24. We need to find what multiplies to 24 and adds to negative 11. What immediately stands out is 3 times 8. If we set them both to negative, they will add to negative 11, and they will multiply to positive 24. So those are our two factors: x squared minus 3x minus 8x plus 24. And now we can factor out an x here, so it's x minus 3. We can factor out an 8, and now again it's x minus 3. And so we have x minus 3 or x minus 8, which is to say that x equals 3, x equals 8. So those are our two solutions, our two roots. And now we just need to sketch the graph of y equals x squared minus 11x plus 2. The graph doesn't have to be so accurate. It's just a rough sketch. It's just meant to be a rough sketch. So we know, for example, it's an upward facing parabola. We have two roots, x equals 3, x equals 8. So draw it something like this. Looks something like this. That's of course x-axis. That's y-axis. We've got 1, 2, 3, 4, 5, 6, 7, 8, and that's 3. So we know we have two roots here. We know it's an upward facing parabola because the equation is the coefficient of the x squared term is positive. So it's going to look something like this. And at the outset, we are told that x squared minus 11x plus 24 is less than 0. What that is to say, in this case, is that we want to find the set of values right here. Oops, if I can draw it somewhat accurately. Like there, right? So basically below the x-axis between x equals 3 and x equals 8. So the set of values in this case, x is going to be greater than 3 and it's going to be less than 8, which is precisely denotes these values right in here, this red line. And yeah, so we're done. That's our set of values. Let's work on another example. Say we are given something a little bit different. Say we are given that 10 plus x minus 2x squared is less than naught. Okay, and now, right, let's the first thing that we're going to want to do is just multiply this entire thing by negative 1. So negative 1 on both sides. It's because we want the coefficient of the x squared term to be positive. So this just basically flips the signs, right? So we've got 2x squared minus x, and now it's minus 10, and that's still going to be less than 0. And now we can just solve is a quadratic, so we're going to set it to equal 0. And we need to find AC, which will be negative 20. And we need to find what multiplies to negative 20 and adds to negative 1. So 4 and 5 immediately stands out. And if we set 5 to be negative, this will multiply to negative 20 and then we'll add to negative 1. So those are our two factors. We've got 2x squared minus 4x, plus 4x minus 5x minus 10. All of that equals 0, and we can factor out a 2x here, 2x. And we are left with x plus 2. Again, we can factor out here a negative 5, and we are left with x plus 2. So we have x plus 2, or 2x minus 5, which is to say that x equals negative 2. Now I'll box that off. Or x equals 5 over 2, which is the same as 2 and 1/2. I'll just box that as well. So in the next step, we found our two roots, two solutions. We just need to sketch the graph of y equals 10 plus x minus 2x squared. So we know it's going to be a downward facing parabola because the coefficient of the x squared term is negative. So that's a good piece of information, and we know that we have a root at x equals minus 2 and a root at x equals 2 and 1/2. So we can sketch our graph like so. We can say 1, 2, right? And this is, of course, the x-axis. This is the y-axis. Okay, and it's negative 2, negative 1. Then we have 1, 2, 3, 4. Just go all the way. So that's 1, 2, 3, 4, 5. So we know we have a root at 2 and 1/2, which is going to be right in the middle here. And it's a downward facing parabola, so we can sketch this. And it's going to look something. No, that's too steep. It's going to look something like this. And our set of values, well, we're told that 10 plus x minus 2x squared is less than 0, So if I just extend this down a little bit like that, it's less than 0. So in other words, we are looking for the set of values of x right here and right here. In which case we can write that the set of values of x will be here. So x is greater than negative 2. X is greater than 2 and 1/2. Because again, if that's not completely clear or immediately obvious, the further this graph expands, like the further we were to draw this expand, you can see that the values for y are decreasing, becoming increasingly negative, the more that x is becoming increasingly positive this way. Likewise for this side, the values of y are becoming increasingly negative as x becomes increasingly negative. So we want to say that, and that's a mistake on my part, I meant to write less than negative 2. X is less than negative 2, because the more negative x becomes in this side, then the more negative y will become, and that's the range of values that we are looking for here. So to work on one more example, say, think of something find something. Say we have x squared minus 9 is less than 0. It's a little bit different to look at, I suppose. The main thing to understand is that we can just simplify this to x plus 3, x minus 3, and of course that's all just set to equal 0, or set to equal 0, and so x equals negative 3, x equals 3. It's fairly straightforward, and so we already have our two values for x. I mean, another way you could have done this actually, one could have just added 9 to both sides. You would have had x squared less than 9. You could have taken the square root from both sides, and you would have had x's less than plus minus 3, and then you would have said, okay, so the root's at plus minus 3. You had it set to equal 0, and on, but nevertheless. So we have x equals negative 3, x equals 3. We need to sketch y equals x squared minus 9. Well, we know, again, that it's going to be positive, or an upward facing parabola, right? Coefficient of the x squared term is positive, so we can just draw a very quick sketch here. Like so. We've got 1, 2, 3, that's negative 3. Of course, this is the x-axis. We should label them. Okay, and then we've got, we've got 1, 2, 3. And we know we have our roots here, it's upward facing, so it's going to, our graph is going to look something like this. I'll do my best to sketch it, something like that. I'll just expand, okay? We are told that x squared minus 9 is less than 0, right? So it's this region right here. If I just try my best to sketch it like so, we need to find the set of values here. So that's going to, we could write x is going to be greater than 3. X is greater than negative 3, I should say, and it's going to be less than 3. Less than 3. That is our set of values.